Well, what holds a compound together? I've told you I think about atoms as being a lot like Lego bricks, and we know that Lego bricks will stick together. They've got those little circles on the top. What is it that makes atoms stick together? They're called chemical bonds. Chemical bonds hold atoms together in compounds. Chemical bonds come from attractions between opposite charges. So within the atom, we know that there are protons and electrons, and we can also form ions when an atom loses or gains electrons. So any type of bond is a result of attraction between opposite electrical charges. We classify chemical bonds in two broad categories, ionic and covalent. Ionic bonds involve ions. So these occur between metals and nonmetals. Metals tend to lose electrons. Nonmetals tend to gain electrons. The result is we have positive ions and negative ions, a transfer of electrons. And so these oppositely charged ions then are attracted to each other like magnets. If we look at the solid phase of an ionic compound, it's composed of a lattice. So there's a regular three-dimensional array of alternating cations and anions. Two cations would repel each other, two anions would repel. And so the cations and anions are arranged in a way to maximize attraction and minimize repulsion. That's a lot like one of those magnetic building toys, where if you put it together in the right way, everything just clicks in together and it sticks, right? Here we have an illustration of the formation of an ionic compound. We've looked at this one before. Here we have sodium metal composed of sodium atoms, chlorine gas composed of chlorine molecules. And what happens here is the neutral sodium atom loses an electron. That electron is gained by the chlorine atom. So the neutral sodium becomes a positively charged ion because it's lost an electron. The neutral chlorine atom becomes a negative ion because it gains the electron. Electrons are not found just running around by themselves. So if one atom loses, another one gains. There's also no homeless shelter where you can just go adopt electrons. So in order for that chlorine to become a negative ion to gain electron, it has to get the electron from another atom. So when this transfer occurs, now we have a positive ion and a negative ion, and they're very attracted to each other, and they'll stick together, and that forms sodium chloride. Sodium chloride, also known as table salt, has properties that are extremely different from those of the elements that are forming it. Sodium metal, highly reactive with water. Chlorine gas is toxic. Sodium chloride is necessary for life. One of the things I would like you to understand when you leave this class is that everything is a chemical, and just because something is natural does not mean it's safe. Anything is toxic if there's too much of it. Too much water is toxic, either because you're drowning or because you mess up the electrolyte balance in your body and your heart stops. Too much oxygen is toxic, right? And yet oxygen and water are necessary for life. So sodium chloride, we need some to live, but too much sodium chloride would kill you, right? That is true for any chemical. Too much will kill you. There's a lot of paranoia out in society about chemicals. Oh, well, I want my stuff to be chemical-free. I remember seeing bottles of chemical-free sunscreen. What's in the bottle? A vacuum? There couldn't even be air in there. A question?
Is there even really a difference between like the pH water that they have? It doesn't seem to do anything.
Yeah, pH water.
It just seems to sound like it would mess up.
pH, yeah, that's, in my opinion, completely bogus.
Yeah.
Yeah. You really don't want to go around altering the pH of your body because, for one thing, your body, if it's healthy, won't let you do that. And if your blood pH changes, you'll die. So, not good. So let's look at the covalent bonds. Co is a prefix that means sharing, right? Covalent means we've got valence electrons that are being shared between two atoms. So this is going to happen between two or more nonmetals. If you have a metal and a nonmetal, the metal's going to lose an electron, the nonmetal gains the electron, you've got an ionic bond. If you've got two nonmetals trying to get together, how would you transfer an electron? They both want to get an electron, and nobody's willing to give one up. So they're at an impasse. So they decide to share the electrons instead. By sharing the electrons, they can form a bond. So here we have an illustration. Here's two positive charges. Those are representing the nuclei of two different atoms. And here's an electron. When the electron is out here somewhere, that does not bring these two nuclei together. Or if the electron's over here, that doesn't bring them together. But when that electron is between the two nuclei, both nuclei are attracted to the electron and a bond is formed. So we call covalently bonded compounds molecular compounds because covalently bound atoms compose molecules. So in a molecule, the atoms are bound by covalent bonds. In sodium chloride, which is also a compound, there aren't any molecules. There are just ions and ionic bonds. That's an ionic compound.